guys. So this is Sriram Rajan. Thank you for joining this webinar. I'm going to talk about governance and how to implement that on top of AWS today. So as an agenda, I'll introduce myself. I'll touch a bit on why governance would be important in a cloud world, how to approach it, look at some common patterns and anti-patterns on it, and then we'll look at the constructs that AWS provides and the tools and technologies that are available for us to automate some of that and implement that in a very cloudy way. We'll leave time for questions at the end, so there'll be about 15, 20 minutes towards the end where we can do questions. So I'll complete everything, and then we'll take questions from you guys. So let me start by introducing myself. So I'm Sriram Rajan. I'm a Principal Architect here in Rackspace AWS Services. I've been in IT for about 15 years. I started as a programmer in computer systems. I worked in networks, worked in security side of things, worked in the US, and now work from the UK. I've been in Rackspace for 7 years. And in Rackspace, I've done a variety of roles from professional services, automation engineering, and now cloud architecture. If you want to connect with me, there's some handles on LinkedIn and on Twitter. Do feel free to contact me directly on that. So let's kick it off. So governance, let me start by saying that governance is a dreaded word. Often if you talk to IT shops, developers, things like that, the minute you say governance, it feels like a bureaucratic process. It feels, I've got to check a few boxes, somehow get these past certain standards and policies. And it doesn't have to be that way. And that's something I'll probably talk today in terms of how to approach it where it doesn't feel like things are being forced upon. You still have autonomy to do certain things, but you do it in a structured way. Often a question is asked when it comes to governance, is it important in the world of cloud? The answer is maybe not on day one. If you're a small startup with 2 or 3 employees, managing everything, wearing different hats, probably not. But let's say you are a large enterprise or you're a startup that's growing at a good rate, eventually it does. And that's the key about it. You need to have some level of governance on cost, control, things like audit, and so forth. And the other thing, this probably applies to people who are switching from traditional workloads in data centers to AWS. If you look at traditional DCs, often things are slow because you have to order a server, get quotes, wait for people to install it, and then install our application. There is some intrinsic slowness in this process, and that almost self-regulates. Come over to the AWS side, often it's click, type a few commands or an API call, and boom, you have the whole environment ready. And what we've seen in Rackspace with customers that we work with, often this becomes a problem eventually where you're like, oh, now there are 42 different test environments, and I don't know if they're secure, I don't know if they're compliant, and also I'm paying a lot for all of these things. So eventually, it does become important there. The other question that often gets asked, does this slow things? Cloud is meant to be agile and fast and innovative. Does adding governance on top slows things? The answer to that is I would give an architect's answer to that by saying it depends on the approach. If you do it right, it probably won't slow at all. It really depends on the approach. And that's why I would like to start by talking about certain patterns or anti-patterns worth thinking about as you implement governance on top of AWS. For starters, what I would say is implement the model in spirit. If you're a large IT enterprise, you probably have a governance model that's documented and well written, but chances are it hasn't been updated in quite some time either. It probably applies to more traditional data centers and workloads. So don't just take a document that's quite old and say, implement the exact same things on top of AWS. Use that model in spirit, but then think of certain agile ways of doing things, think of certain tools that you would use to implement them. So that's something very key when you approach a governance on top of AWS. The other thing I would like to say is don't stifle experimentation. What I mean by that is cloud is quite successful because it allows developers and IT to innovate and experiment and come up with new solutions. So don't stifle that by saying there's only a list of approved things that you can do. Probably a better approach would be to say, hey, you're using these new products. AWS released Elastic File System. Let's start looking at it and use that to build some best practices model rather than stopping people from using it. Make it easier to conform. This is important, especially if you want to build this in an autonomous way, is to say, if you follow this model, we'll give you these things. And I'll touch later on certain things like templates that you can use to provide something back rather than force people to follow a checklist. So you can say, hey, use our model. This is fully automated, has these things that you will get but just by using it. So make it easier to conform rather than forcing like a checklist of things on people. And then finally, in terms of the approach, iterate. AWS is a huge ecosystem. There's a lot of products. So don't spend 6 months building a governance model for every single AWS product. Start with a core set of services. Start with a core set of framework. Start with that, and then iterate over time and keep adding new things. What we have seen often with customers, there's a core set of products, things like EC2, VPC, RDS, which is pretty much the main components that most customers use. So it's always good to start with those things and then build other things on top of that. So having said that, let's now move into the constructs and the tools of the trade. So I'm going to touch on really 6 topics. I'm going to talk about 3 constructs or abstract things that you can build as a model, be it in documentation, be it in actual practice. And then I'm going to talk about 3 tools that AWS provides that kind of help you build this in a more cloudy and autonomous way. So the first one is accounts and VPCs. So a quick recap for those who are new to AWS. The account is really the highest level of isolation in AWS. This is what you get when you first create the account and provide your credentials and things like credit card details, is basically get a construct in which all the services exist. It's the billing entity. This is where all your bills come, so there's a billing section for that. And then things like service limits in terms of how many number of instances that you can spin up, how many VPCs you can create are applied at the account level. The VPC is another layer. Sits inside the account. It provides logical isolation. It stands for Virtual Private Cloud, and it's exactly that. You create a construct inside that allows you to create your own network segments, so you can segment it based on the way you want to build your subnets and patterns and things like that. And then you can configure a lot of services inside that. Not everything is VPC aware. There's probably a huge set of AWS services that can be built inside of a VPC, but there are still quite a few that are not. Things like API Gateway, things like Route 53 are actually outside of the VPC, so that's something to keep in mind. So how do you approach this in terms of a structure, in terms of a management layer? So on the account side of things, our recommended best practice is to keep accounts separate where possible. So create separate accounts for different teams or business functions. You could even create separate accounts for production versus staging versus development. In many ways, the account is the best way to separate workloads or separate functionality. It also limits the blast radius, and what I mean by that is any compromise that can happen to, say, credentials and things like that is kind of contained within that account. And also, if you have a rogue developer or something, again, that can be restricted to specific accounts. Some people might say that's a bit of a management burden to create that many accounts, but it's actually not. Often it's fairly easy to manage these accounts, and there are tool sets available to manage multiple accounts in a very centralized way. And that leads us to the second part of managing these accounts is to create the master plus link model. So let's say you have 10 different accounts. The best way to put them is to structure them under a master pair account, which gives you an ability to have a single aggregated bill. You also have shared benefits of things like reserved instances and pricing tiers and so forth. So you can create separate accounts, but still kind of manage it from a commercial perspective from a central location. In Rackspace, the way we approach it is very similar. We have a home control panel which allows customers to provision several different accounts and kind of manage them centrally. Then on the VPC side of things, certain rules that help from a governance structure. So we go with the model of having one VPC per account. This mainly, I would say, only do it where possible and allow exceptions for most cases. As a general rule, you should be able to get just one VPC per account, but there might be some edge cases. For example, you may want to deploy VPC in multiple regions and things like that. So those are the cases where you may deviate from that rule. And then a shared services VPC will help in providing a better structure to the way you do certain services. So no matter how much you separate accounts and VPCs, you'll eventually find that there will be some services, for example, logs or security tooling or deployment managers like, say, Octopus Deploy or CI tools like Jenkins that may need to be in a shared place where they can access multiple environments and accounts. So in that world, you have to consider a shared services VPC that sits in a separate account. And then it becomes sort of like a hub and spoke model of a shared services VPC and a whole bunch of accounts that talk to it, or the other way around. And finally, with these things, documenting defaults and standards is important, or agreeing on those across your company, across your teams is very important. There are several ways to do certain things in AWS. AWS provides you a wealth of options on approaching things. For example, you can do access controls in an access control list or security groups, and there are pros and cons to sort of those things. So get those decided. So what should be enabled by default? And I'll touch a bit later when we talk on technologies like CloudTrail. It'll be good to enable certain things by default. And then what about naming conventions? How do you name VPCs or the resources inside it? What sort of subnet structure that you want to follow? How are you going to implement NAT, Internet, or VPN gateways inside the VPC? All those things, it's good to have a standard pattern for those things, and then keep them consistent across all these accounts and VPCs. The next construct we're talking about is IAM. So IAM stands for Identity and Access Management. AWS provides a centralized model of managing all your resources, permissions with it, and effectively these are the keys to your kingdom. IAM, like any identity system, provides a good subset of features in terms of managing users, groups, roles for these users, and then policies that you can implement. Policies are really JSON documents that you can define certain conditions to be met. For example, you can say, for the dev account, allow logins only during business hours, and so forth. So IAM is very key to how you would manage access control across all your AWS accounts. And with IAM, or with like any identity management, the best practice is always to follow a least privileges model. So create users that are given only the privileges they need. But I would also caveat that by saying this is always a trade-off between usability and security. Sometimes IAM policies can get very complex if you become too granular and become harder to manage, and they become an administrative burden on their own. So depending on your culture, the way you apply these in your enterprises, try to find the right balance of allowing usability while still maintaining security. And then manage IAM centrally. There are several ways to do this. You can do it within IAM, where you can create users and roles that have access to other accounts, and you can do cross-account roles. Or you can use federation. So if you're an IT shop that's running things like Active Directory locally or other authentication providers, you can tie that to IAM with things like SAML, and then use it that way. Another feature that we do in Rackspace is exactly that. Our own control panel sort of does a federation into the account using IAM. Then think about credentials. So credentials, for starters, the best practice says don't use the root credential. So the root credential is something that you get when you first create an account. This is the root user on the account. Avoid using that anywhere at all costs. Lock it away, almost never use it. Then use temporary credentials where feasible. This probably applies more to the application and how you work inside that. IAM provides a good feature set in terms of using temporary credentials, which are a good security practice to do. And then where humans are involved, good to have multi-factor authentication enabled. This gives you certain protections in terms of access, and you can also lock down certain things requiring MFA for deletion and things like that. And again, like the VPC and account structure, it's good to have a convention for names, resources, and access patterns. So having an agreed pattern, agreed model on how you would implement IAM with the users, groups, and roles is good to do initially. The next one I want to talk about is tagging. Tagging is basically text fields that provide metadata. So this could be, most common tags are like name, or it could be tags around teams, projects, type of environment, and so forth. There's a lot of flexibility in terms of naming the tags and the content within it. Tags are extremely powerful in cloud, especially in a world where instances may come up on their own through autoscale methods. Lots of environments are spun up and down. Tagging provides a great way of organizing, filtering, and searching for resources. You can use tagging with automation, so you can run certain automation based on certain tags. You can define IAM policies and control using tags as well. And then you can also associate tags with cost. So with tagging, again, there's a theme here about getting some conventions right. So a consistent convention for tagging is very important, that you agree across your different environments into what tags to use and what tags are a must-have, what tags are nice to have, and things like that. So that needs to be agreed. This can be based on business units, departments, applications. Really, there's no right or wrong answer to a tagging thing. It's just having a convention that is uniformly applied across these things. Cost allocation tags, worth mentioning that these are separate. AWS publishes a list of tags that are cost-specific. These would appear in things like the Cost Explorer in AWS, your billing reports. So it's good to have these tags present because at the very least, they provide you separation in terms of costs. And then the tags define the governance actions. So have a bunch of rules that say these tags are needed, and then you have to define what to do with it. At the start, you can start with notification. So you can say when tags are missing, notify the groups that created those resources, notify some central team that's managing this for them. And at the other end of the spectrum, you can go to some automation where you say, if these tags are not present on these resources, I'll just delete them. These sort of models are followed by companies like Netflix. There's tools called the tag bot that kind of enforce these tagging rules, and then they enforce it in a very automated way. It's probably not a good thing to do on day one because you need to get your team up to speed with that, and you need to get that culture of tagging going. So it's probably something that you would aspire to, and you will slowly get to it, maybe start with the notification, end with that. So we talked about the counts, VPCs, IAM, and tagging. Now let's look into some tooling that kind of helps with some of these things. So the first thing worth addressing in this set is CloudTrail. So CloudTrail inside AWS provides a history of all API calls. Simply put, CloudTrail will answer the question, who made an API call to change something? Then there's another tool called AWS Config, which basically provides resource inventory and configuration history. And that effectively answers the question, what does this resource look at a particular point in time? So these two tools provide while one provides a great audit trail, the other one provides a way of governing the configuration as well. Config rules provides custom rule set that you can define and create yourself, and they will all log to CloudTrail. So you can build these rule sets there. One thing to keep in note, not everything is supported in config today. There are CloudTrails available for all AWS products, but config is only available for a limited subset of AWS products today. Of course, like anything in AWS, they'll keep adding other things to it over time, and so it will grow. So how do you approach this from a concept of governance? So First, create them at account creation time. So enable CloudTrail in all regions, even in the ones that you wouldn't be using. This is good practice because often you may accidentally create resources in, say, the Tokyo region where it should have been in the US only. And the only way to track and find these things out would be to enable things like CloudTrail and then run some kind of reports on that. So as a default practice, at account creation, enable CloudTrail. And this is a practice Rackspace applies to all our customers. When we provision a customer account, we enable CloudTrail across all regions. You can also aggregate CloudTrail because we can make them logged to an S3 bucket, so you can aggregate them into a central location. So that's something you can, if you have a central security team that wants to analyze these logs in a central place, that can be implemented. Config rules are pretty powerful. So we touched on things like tagging. You can define rules to, for example, detect improperly tagged resources. So you can build these rule sets where it alerts you when certain things don't conform to your standards. And the AWS Lab Git repo has a huge list of AWS rules that you can just inherit and use it across your accounts. So as we move through the layers, so we've talked about the constructs, we talked about CloudTrail, we've talked about Cloud Config. Next up comes CloudFormation. This is where all the stuff we've been talking up until now gets implemented as code. So infrastructure becomes code at this point. So all the account defaults that we talked about, all the VPC structures, naming conventions, CloudTrail being enabled in all regions, Cloud Config rules, all can be implemented in the form of a CloudFormation template. And what CloudFormation does is it allows you to implement all these best practices and standards in code, and it becomes repeatable, it becomes reusable. The good thing about CloudFormation is it can be built in layers. So you can start with a base network, so you can have like a base template for how your VPCs and networking is done, maybe a set of security controls on top, then the application, and then possibly things like monitoring and other operational stuff. You can also build them very generic using conditionals and parameters. So for example, you can say, if this is a dev environment, allow only these types of instances. And then you can parameterize them by saying, let the end user select the type of instances as well. So what CloudFormation does because of all this, it creates a very customizable template. So you can build these templates and then share them across your teams, and they can start consuming them. It actually saves them a lot of time in building and provisioning these resources, but at the same time, it also allows us to conform to certain standards and certain rules. With CloudFormation, it's important to document these things properly because it makes it easy to use. So as you build these templates, provide some documentation on the guiding principles for the templates, what it provides, what it doesn't provide, things like that. Make them easy for people to just look at a library of templates and start using them. And then once you have these templates, you have a standard, but then you're also giving people some autonomy to say, hey, take the base network template, layer your stuff on top, and then you're up and running. And start with some base services, but then try to include templates for the most common applications or services that you would use. So maybe start with your networking. Over time, maybe add stuff on how you would manage security groups, for example. Build something for RDS or Elastic MapReduce. So iterate and include more and more services onto that. And the next layer on top of on CloudFormation comes the AWS Service Catalog. Now, Service Catalog is basically a self-service model for everything that we've done so far. So it layers on top of CloudFormation, and it creates a model where an IT admin creates a catalog, which is basically a portfolio of products, and then your developers or other teams just consume. So they log into a console. You can lock the AWS console to the point where it only shows the service catalog and nothing else. So it gives them a very clean interface of what to provision. It layers on top of CloudFormation, so you still need to build those things. So you need to build your CloudFormation templates and then use them in your catalogs. The bells and whistles that Service Catalog adds on top of CloudFormation is you can customize it a bit more. So you can add user-friendly descriptions on what the products are. You can even add your own logos and images to it. You can add support emails for you can say this product, email this IT team for support and questions. So you can customize it based on how your own company works in that. We talked about tagging before. Service Catalog makes these tags immutable. So you can incorporate those tagging, and they become to a point where they can never be changed, which is great if you want to have these tags persist and be consistent across all the environments. It also exposes the CloudFormation parameters in a more user-friendly interface. So things like instance types or sizes are available now for the users to customize and pick and choose in there. And then finally, Service Catalog can also be shared across all accounts. So you can create accounts in these catalogs in a central place and then share them with different AWS accounts that you're managing. So we've covered the whole set of tools. I want to talk about some existing options that are available essentially through AWS Labs, through other service providers, or just in general in open source communities and things like GitHub and so forth. So the first thing is CloudFormation templates. We're at a point where there's so many quick starts that AWS provides. Rackspace would provide our own versions of those accounts and VPC templates. For example, we have a standard Magento template as well. So leverage stuff that has already been built. So don't reinvent the wheel. Look at these quick starts. Look at these templates that are available, and then customize them. Often these are built by teams that have solid expertise in CloudFormation. They've gone through several rounds of testings and improvements, so they're easy ones to pick and customize a bit. And the other thing we talked about was having governance rules and figuring out how to look at things like deviations, so things like Cloud Config, AWS Config. There are also other tools that provide similar functionality that look at your AWS ecosystem and what you're consuming, and then provide value-add services. So one example of an open source product is Cloud Custodian. This is from Capital One. It's a rule-based engine where you define a certain set of rules for how you would deploy an AWS environment and manage it. And then you can define actions on when those things happen. So it's a good one to look at if you want to do some extra stuff that some of the native tools don't provide. Then Rackspace has a tool called Compass, which basically provides opinions and reports. So it runs on your AWS account and then provides cost analytics. It provides security analytics. It provides best practices and deviations from those best practices. So it provides a whole bunch of reports and alerts when certain things don't conform. So those tools, again, will help you govern them in a more loosely coupled way, where you still let the developers run what they're doing, but then you kind of oversee this by running these tools and then making sure that they conform to certain standards and practices. So we kind of covered most of the stuff. What I would like to say is there is a lot more. We could probably have done a couple more webinars in depth in some of these technologies and tools, but hopefully this provided a good enough landscape of tools to start looking at when you start implementing on governance. And what I would like to end with is to say, don't ignore governance. It eventually will matter. Eventually you would be required to do audits. You'll be required to be compliant as your business grows. So it's something that you have to plan from day one. It's easier to implement initially than force on later. So start early on that, but allow for experimentation. So make sure that you still allow your teams to leverage cloud and the innovation that it brings in a very agile way. Automate. So look at CloudFormation, look at Cloud Config, AWS Config. Try to implement some of these in a very cloudy way where things are inbuilt and sort of self-governing in some ways. So definitely look at automation. And then iterate. So start with some baseline frameworks and then expand as you go further into it. And then if you want to discuss more about these things, Rackspace can help you with these things, so reach out to us, and then we can have more discussions on these things. You can also reach out to me directly through my Twitter and LinkedIn handles. I have a few more references that's worth looking. There's a lot AWS provides in terms of best practices, CloudFormation templates. There's some white papers on implementing governance and automating governance on top of AWS. So I would encourage you to read those in your spare time. And then finally, reach out to us. So there's a lot of stuff that's there on the Rackspace side of things in terms of what we provide on a managed AWS offering. There's a blog there as well in terms of how we're approaching certain things. And there's a bunch of customer stories as well on how customers are using AWS with Rackspace. So at this point, I would like to open up to questions. I'm going to look through the channel and start looking at it. All right, so I'm going to answer the questions in the order that came in. The first one was, are there any challenges when deploying across accounts? For example, staging account to a production account. So there are some challenges in the sense you may have to do some shared resources depending on how your deployment model works. So one use case that I've seen with customers is if they have a deployment tool, for example, Octopus Deploy, which is quite popular with Microsoft and Windows environments, or using things like TeamCity and Jenkins, is to where to host those services. Would they go in production? Would they go in staging? Is they kind of touch both environments? Often the best option there is to put them in a more central location, like a central VPC, and then talk with that. You may have to figure out certain access patterns in terms of how these services are accessed. So are you using the push method for deploying these things or pull? Each one will have its own considerations on where to open network ports and services and things like that. So there are a few challenges in that, but largely most of them can be overcome by just proper design practices. So I would encourage doing that. So the next question was, how familiar are auditors, example, PCI, DSS, QSAs, with AWS platform from a governance perspective? The answer to this is they're getting increasingly familiar. So if you roll back 4 or 5 years, probably, there was a general feeling that cloud is not secure, is not suitable for compliance-style workloads. I think that perspective is changing. We see a lot of customers who have achieved PCI compliance, HIPAA compliance on top of AWS and with Rackspace services. And auditors and QSAs likewise are getting up to speed as well. AWS provides a lot of material for compliance things. For example, most of their services are ISO 27001 certified. They also have PCI, HIPAA, and several other compliance stuff. And they'll provide detailed documentation on how their products and services will adhere to it. Of course, there's still a shared responsibility world where you are building stuff on top of AWS, so you're responsible for areas of governance in there. And that's where you have to prove to your auditor that the right controls are in there. Things like CloudFormation will help. For example, you can make a case that that's probably the best way of change controlling an environment, best way of keeping two environments in sync. Things like CloudTrail provide a great level of audit on the AWS side of things. And things like Cloud Config will provide more rule sets. So it's a question of working with the QSAs and saying all these concerns can be addressed, sometimes with proper tooling, sometimes with more governance-based manual processes. So the next question was, can tag searches use globbing? For instance, if my standard format is business unit project type, can I search for a business unit project to find all tag types for a project? I'll be honest, I don't know the answer for this off the top of my head. I think it allows that, but I'm not 100% on that. That's something we'll check and read through the documentation. So the next question was, what sort of integration is available between AWS monitoring tools and current commercial offerings that may exist on-premise? So there's some integration. It depends on what level you're talking. If you're looking at the operating system side of things, then it doesn't change much. Often these tools will have agents that you can deploy on any Windows or Linux operating system, and they can be integrated back into that. Some of these tools have now started providing additional tooling for monitoring of specific AWS services, say, for example, RDS and so forth. So that integration is getting there. Tools like Datadog are providing AWS-specific components for monitoring. So it's a growing tool set. If you're looking at operating system, it's all for today. On the other one, there may be some integration that you may have to do manually through APIs and CLIs, or you may have to look at a tool that's already doing integration for you. Okay, that looks like it was the last question. So thanks everyone for joining. Hopefully this was a useful session. This webinar will be recorded, and we'll share the link with you if you need to come back for any other topics there. And then if you have any questions, there are contact details available in this as well. So do reach out to us, and we can help you with your questions. So thanks for joining. Have a good day.